Hello everyone, you are welcome to another video session of Python for All. In this video, we will talk about building blocks in Python part 3. We will further our discussion with PEP 8. Here, we will look at other recommendations. Avoid trailing white spaces anywhere. Look at this example where you have the correct way of writing it and the wrong way of writing it. In this example, you see that we have inserted trailing white spaces where necessary. And if you look at the wrong way, you will see where trailing white spaces have been omitted, even when it is necessary, and where they have been inserted where it is unnecessary. So ensure you avoid trailing white spaces anywhere. Put them in the right place, before and after any binary operator, after and closing brackets, and so on and so forth. Next, we look at function annotation. Function annotation should use the normal rule for colons and always have spaces around the arrow if present. Let's see a code snippet of this recommendation. Here, the right way of writing it is shown in lines 2 and 3, while the wrong way is shown in lines 7 and 8. Just right after the function py4a, you have an input which is annotated by as any string. And also on line 3, you have the function which is annotated as a positional integer. You can see the white spaces after the parentheses and before and after the arrow. And also right inside the first function, after the colon, you see a white space. The wrong way is as shown in lines 7 and 8 where there are no white spaces left. When combining an argument notation with a default value, however, use spaces around the equal sign. Let's see an example of this in the next code snippet. The correct way is right inside the function py4a, where we have the input argument sep being annotated as any string. You can see the trailing white spaces left after the colon and before and after the assignment sign equals. So also you see an example demonstrated on the next line, which is line 3. You see where we have annotated the input and sep argument, but the limit has no trailing white space before and after the equal sign. This is what you do when you have default arguments, you don't leave trailing white spaces. The wrong way is as shown in line 7 and line 8. Next, compound statements. Multiple statements on the same line are generally discouraged. What PEP 8 says here is that do not put compound statements on the same line. In other words, split compound statements over multiple lines. Let's look at this code snippet. You see the correct way of writing it as represented from lines 2 to line 6. If foo equals blah, do blah thing. And then do 1, do 2, and do 3. Then look at the wrong way of doing it. Here they have placed the conditional statement if on the same line with do blah thing. And then do 1, do 2, and do 3 on the same line and separated with a semicolon. If you see something like this, it is not Pythonic, it breaks readability, and it is wrong. Next, while sometimes it is okay to put an if, for, while with a small body on the same line, never do this for multi-clause statements. Avoid folding such long lines. What do we mean by this? Let's look at this next code snippet to explain what PEP 8 is actually talking about here. The wrong way is if foo equals blah, do blah thing for x in list, total equals increment by x, while t is less. You see, all of this, you see, they are conditional. The if statement, the for loop, the while statement, they are all put on a single line. That's the wrong way of doing it. Also, look at the next example of also the wrong way of doing it. If foo equals blah, do blah thing, else do non-blah thing. We see another example, try something, finally clean up. And then you see do 1, do. All of these examples are the wrong way of doing it. The right way is to split these statements over multiple lines. Comments. Inline comments. Use inline comments sparingly. Inline comments should be separated by at least 2 spaces from the statement and to start with a hash symbol and a space. What we mean here is that separate every inline comment with at least 2 spaces. So 2 or more spaces, and then it should start with an hash symbol followed by a space before the comment. Let's look at an example in the next code snippet. Here you see it says unnecessary and distracting if it states the obvious. Here we are incrementing the variable x by 1 and then inserting a comment saying increment x. It is obvious, so it is unnecessary and distracting. But look at the next example where we have written x being incremented by 1 and we say compensate for border. Putting that statement compensate for border gives description of what we are doing, and it's appropriate and makes readability better, unlike the previous example stated on line 2. Documentation strings. Convention for writing good documentation strings, also known as doc strings, are immortalized in PEP 257. If you go through PEP 257, you will see the standard convention for writing a good documentation strings. We'll look at that subsequently in our videos when we begin to talk about functions, and also when we get to object-oriented programming when we write classes. Look at this example in this code snippet. You see, the documentation string begins with a triple quotation mark followed by the content. Here we have return a full bang and then breaks down into the next line. Optionally plot says fabricate biz bar first, and then there's a closing of that doc string with the same triple quotation mark on the next line. Here you can either use the double quotation mark or the single quotation mark, but whichever one you use, ensure that you are consistent throughout your code. For one-liner dot string, please keep the closing triple quotation mark on the same line. That's the example. If you have a one-liner dot string, you begin the triple quotation mark on the same line, put your documentation, and close it on the same line. Naming conventions. Here we'll look at descriptive naming styles. First, B, single case lower letter. Next, single case upper letter. Next, lowercase. Next, lowercase with underscores. Next, uppercase. Next, uppercase with underscores. Next, capitalized words or cap case or camel case. Note, when using acronyms in cap case, capitalize all the letters of the acronym. For example, we have HTTP server error is better than writing HTTP server error, where you have the TTP written in lowercase. It's better to capitalize the HTTP, and then you have the cap case written for server and error. All of this naming convention can be used to name your variable, your function, your classes. We'll see that subsequently when we get to function name, module names, class names. Mixed case. You can also use mixed case to name your variable, your function, your classes, or your module or packages. Capitalize words with underscores. It is ugly. Do not do it. You also have single leading underscores. Next, we have single trailing underscores. These are used by convention to avoid conflict with Python keyword. For example, class underscore. Also, in this code snippet, you see here we have inter.top level, and then we have the argument as master, and class underscore equals class name. Here, because we have the class keyword in Python, so we cannot use it. So to avoid such conflict, we append a trailing underscore. Next, we have double leading underscores. When naming a class attribute, this invokes what is called name mangling. We will discuss name mangling in our subsequent lectures, and then you have a clear understanding of what name mangling is. Next, we have double leading and trailing underscores. These are often referred to as magic objects or attributes that live in user-controlled spaces. For example, double underscore init double underscore import double underscore main double underscore, or double underscore file double underscore. Next, prescriptive naming conventions. Names to avoid. Never use the character L, lowercase, or O, or I as single character variable names. Package and Moodle names. Moodles should have short or lowercase names. Underscores can be used in the Moodle name if it improves readability. What we are saying here is that all Moodle files should be all lowercase. You can use underscores if it improves readability, but it should be avoided. Python package should have short or lowercase name, although the use of underscore is discouraged. For packages, short lowercase names. Next, let's look at class names. Class names should normally use the cap word convention. In other words, capitalize each word. Exception names. Because exceptions should be classes, the class naming convention applies. Function and variable names. Function names should be lowercase with words separated by underscores to improve readability. Variable names follow the same convention as function name. Miscase is allowed only in context where that's already the prevailing style to retain backward compatibility. Otherwise, don't use mixed case. Method names and instance variables. Use the function naming rules. You have a better understanding of method names and instance variables when we get to object-oriented programming and we talk about classes. So when defining method names and instance variables in a class, follow the function naming rules. In other words, use all lowercase or lowercase with underscores. Use one leading underscore only for non-public method and instance variables. We would explain what we mean by non-public and public methods when we get to object-oriented programming in detail. To avoid name clashes with subclasses, use two leading underscores to invoke Python's name mangling rules. Like I said earlier, we will discuss extensively in our subsequent videos what name mangling is, and then you have a better understanding of this recommendation. Constants. Constants are usually defined on a Moodle level and written in all capital letter with underscores separating words. For example, max overflow and total. Programming recommendations. Use is not operator rather than not is. While both expressions are functionally identical, the former is more readable and preferred. You will see examples of this very shortly. You see here, the correct way of writing it is if foo is not none. But the wrong way is if not foo is none. So if not is the wrong way because it hurts readability. But if foo is not none is the right way because it improves readability. Always use a def statement. In other words, always define a function rather than use lambda expressions. We'll explain what lambda expressions are when we get to functions, and then we'll talk more about that in our subsequent videos. This is an example of that. The correct way of writing is to say def f of x and then you return 2 times x. But the wrong way is using a lambda expression and having f equals lambda x, returning 2 times x. Do not use the lambda expression, rather define the function. Derived exceptions from exception rather than base exception. Direct inheritance from base exception is reserved for exceptions where catching them is almost always the wrong thing to do. What this recommendation says here is that always derive your exceptions from the exception class and not the base exception class. You will see that also when we get to error handling and exceptions in our subsequent video. When catching exceptions, mention specific exceptions whenever possible instead of using a bare except clause. This is an example. Here we are using a try except clause. So we say try, import platform specific module, except import error. Platform specific module equals none. So here we don't just leave a bare except, but rather we call that except with an import error. For all try except clause, limit the try clause to the absolute minimum amount of code necessary. Again, this avoids masking bugs. What do we mean by that? Let's look at it in this code snippet. The correct way of saying it is say try, value equals collection key, except key error, return key not found of key, else return handle value of value. The wrong way is to say try, and then you see a comment too broad, return handle value of collection key, except key error. And then you have a comment there which says will also catch key error raised by handle value, return key not found. The second way is the wrong way of doing it, as it would introduce subtle bugs and makes it very difficult to even catch bugs in your code. So do it the correct way, which is expressed from lines 2 to 7. Be consistent in return statements. Either all return statements in a function should return an expression, or none of them should. If any statement returns an expression, any return statement where no value is returned should explicitly state this as return none. And an explicit return statement should be present at the end of the function. What do we mean by this? We will illustrate this and explain it better with this next code snippet. Here, the correct way of writing it is, we have a function foo that takes an argument x, and then right inside the function block we have an if statement that says if x is greater than or equal to 0, return the square root of x, else return none. In the same vein, you have a second function bar that also takes an input argument x, and then you have a conditional statement that says if x is less than 0, return none. And then you have return the square root of x. So you can either do it these two ways. The wrong way of doing it is to say you define the function foo that takes argument x, and if x is greater than or equal to 0, return the square root of x. And then there is no x clause, no other further return. It is wrong. Also, look at the bar function that takes x as input or as argument, and then there's a conditional that says if x is less than 0, return the square root of x. So that return is there. Do not do it. It should return at least, if it's not returning an expression or a value, then it should return none. Use .start with and .end with instead of string slicing to check for prefixes or suffixes. What do we mean by that? Let's look at this example. The correct way of saying it is if foo does start with bar. In other words, if foo starts with bar. But the wrong way of saying it is to say if foo and then you slice the first 3 elements of foo and then equal to bar. Do not slice strings to check for prefixes or suffixes, but rather use starts with and ends with. Object type comparison should always use is instance instead of comparing types directly. What do you mean by this? We'll see this example also. The correct way of saying it is to compare the objects instance as integer. Here, if instance object is integer. But the wrong way is to say if type object is type 1. It is wrong. Do not compare objects type with type of an instance. No, use the instance to do the comparison. For sequences, strings, lists, tuples, use the fact that empty sequences are false. What do you mean by this? The correct way of saying it is if not sequence. If sequence. The wrong way is to say if length sequence. If not length sequence. Don't compare Boolean values to true or false using the double equal sign. The correct way of doing it is if greeting. The wrong way is if greeting is equal to true. Also wrong if greeting is true. Finally, use of flow control statements, return, break, continue, within the finally suite of a try finally, where the flow control statement will jump outside the finally suite is discouraged. It is wrong to say def full that takes no argument, try, and then you have 1 divided by 0, finally return 42. Do not do this. So what PEP says that do not use either control, break, or continue outside the try, except, finally statements. With this, we have come to the end of this video. Like this video, share this video, subscribe to my channel if you have not done so, and do not forget to hit the notification bell to get notified of new upload. Until then, I will see you in my next video.